All right. Hi, everyone. I'm Evan. I am a teacher, fourth year teacher at Avon Old Farm School, which is a independent school outside of Hartford, Connecticut. This is like I said, fourth year teaching. I've been doing AP Computer Science A for just finishing my third year now. So relatively new to the whole, education world. But I'm here to speak about auto grading and its use. I was first kind of brought to auto grading in my college years. I was a computer science major, and all of my assignments would pass through an autograder before they actually, made it into a TA's hands to look through manually and read my code. And I found that autograder feedback to be very useful as a student to figure out if my code or part of my code is functionally correct, but I had really no idea how it worked. Going into the teaching side, I eventually found CodingBat, like an online website for testing the kind of small Java functions. And then when I eventually made my way over to the Coding Rooms platform, I immediately just got going with auto grading. It takes a little bit of time to set up, and I mean like a little bit. It's not a very complicated process at all, and it's wound up saving me a ton of time, both while I'm teaching and while I'm grading later. If I'm going around my classroom during some project or some assignment, I don't have to worry about a student raising their hand and asking, is my code correct? Is it working okay? They can hit run tests and they can know if their code is going to work, or if there are certain errors that they might be able to sit and figure out themselves before raising their hand and getting my attention, which gets me through my material a lot faster. My first year before I had my own kind of grading setup going, I was constantly going person to person, just trying really hard to get anybody's code to work, or at least point them in the right direction. I find that this sort of software can really get people motivated to solve their own problems before bringing them to me, which lets me, the expert in the room, have a little bit more challenging problems to work with instead of the little stuff that kids can figure out on their own pretty easily. So in this video, I'm going to invite you to a demo classroom that I've set up on Coding Rooms. Let me get the link to that in the chat. And we'll just go through a few assignments talking about different formats of auto graders that you can set up. And they're super easy to use with Coding Rooms. And ideally coming out of this, if you have any questions, we can talk about them at the end, or just throw them in the chat at any time. And ideally coming out of this, you're able to write your own auto graders for your own assignments, either for what's left for the school year, or as you prepare for next school year with any of your Java assignments.
As Evan's getting that link, each example Evan goes through today will be available on the Coding Rooms Marketplace, ideally tomorrow or sometime tonight. So each example from the teacher side, you'll be able to make a copy of from the Marketplace as of tomorrow, and I'll email all the registered people a follow-up with the direct link to the Marketplace.
Great. All right, so I just posted that link in the chat just a moment ago. I see we have 2 people already in. Welcome. I'll give you a couple of moments to get settled in there, and I'll set up my screen sharing so you can also see my teacher view on our Zoom link, and then you can also see what the students are seeing, play around with some of the assignments that I've set up, and try to get some examples of like an error output or some correct output as well. All right. Seeing my people page here. Okay, so I have a few assignments. We'll talk about input-output testing first, and then get into unit testing a little bit later. So input-output testing is a very, very simple way of interacting with the student's code. It might be what you would use when grading their code in person, like running their main method and just typing things into the console and seeing what comes out the other end. So I've set up one assignment right now called Hellocoder. And the purpose of Hellocoder is to get the user to type in their name, and then we will print out hello, your name. And that's all it is. It's the hello world with a little bit of input. And in the template file, I've already given you a method that works. When you hit run, if you type in your name, we'll just let the instance boot up here. type in your name, prints out, hello, Evan. Pretty straightforward.
I'm sorry to interrupt. Can you
Yes.
enlarge the font? I can't see it.
Oh, sure. Yeah. Let me see here. Is that better?
Yes,
Okay.
a little
Awesome.
bit.
Let's see. If I make it too much larger, I run out of.
And on the
There we
right
go.
hand side too, Evan, click on the little lightning bolt.
Yeah, that's
the
good.
lightning grader, close that up too.
Ah, okay. Is this good for people?
Yes, thank you.
Great. Thank you. All right. So yeah, I have a program right here. I just prints out hello and then your name. Let me show you what an autograder might look like for this example here. If I go over to the test bench window, we can see I have one test case called Priya. And I assigned it 1 point. You can assign autograders as many or as few points as you like. And it'll award up to the full amount of points based on the test's success or failure. For this input-output test, I'm using my choice of compare method here. I say it contains an exact value at least once. I'll show you another example of this when we make a new test for this in a moment. But here I specify an input in this sort of top box here. So that's what's actually being typed into the program. I'll type the word Priya in my autograder. And then on the output side, we're expecting that somewhere in the student's output, it'll say, hello, Priya. So with this sort of test where it contains an exact value, we could be typing, the student could be printing out lots of other things before or after their print message, but as long as it contains this string somewhere in the output, it will consider it a pass. If on your own, you want to go into your student page and type some other stuff around it, you'll see that you still pass it. But if you mess up the formatting on the inside of the string, it will no longer pass the autograder. So if I go up and I want to make sure that my autograder actually works the way I expect it to, I can run it either on the template, or if I had a model solution, I could also run it on the model solution. So I hit run tests, runs them, and we see that we passed our test with Priya. And if I expand the output, it'll say hello Priya for the output. That was the actual output, and then it matches the expected output, which it shows right here. So the input is Priya, the actual and the expected output are both hello Priya. I'll show you a different form of very similar test case. I'll go to add test case right here, and I'll just type in a different name. I'll type in Joe because he's second on my list here. Keep it as input output comparison. And now I'll go for flexible equality. So that means if there's an extra new line at the end, or maybe they have a trailing space at the end of their sentences, something like that, like a very small mistake that would be hard to spot. It doesn't, if that doesn't matter to you, like the exact formatting, then you can choose to ignore that, which is really good for especially beginning students who are just trying to get the bare bones down without all those kind of fine details. So we'll say, input Joe, capitalization will, actually for flexible equality, case doesn't matter here. So we could say input Joe, and then output, it should match hello Joe, but their output could be lowercase h. We could add like an extra space or a new line at the end. It doesn't really matter. If I hit run test on the template, it'll show that Joe passed. But if you go into the output, it's still going to show some red. That confuses my students, especially at the beginning of the year as they're getting used to this autograder output. They don't notice the most important thing, which is that green passed thing up in the corner where it says passed. Instead, they go right to the autograder's output and they see that there's red and they think that they failed. The red indicates that there's a difference in between the expected output and the actual output. That's not an actual problem. As long as they pass it, that's okay. All we're saying here is that the expected output had hello Joe with a new line and then something else on the next line. The actual output did not have that. I hope that's clear. If I'm being overly clear, please let me know. That's one assignment. I'm going to show you another one that has kind of numbers as well, but it's the same basic idea. If you go to the next assignment in our Java autograding demo course, we get the 5-year plan. So for this one, I have a blank template besides just making a new scanner object. And your goal for this project is to ask the user what their current age is right now, read that in as an integer, and also ask in what their goal, location is where they want to live in 5 years. And then print out, when you are that age in 5 years, confirm that they'll live in that city or that state or wherever. We're going to use the contains autograder verification to make sure that it prints out the right number and the right city. But here we don't care about the exact format at all. As long as it contains those two attributes, will be good. This is really good for intro students who want to print out a personalized message and you can't possibly keep track of all the different formats of their code. They'll print out a different confirmation. And that's also good for letting students have different code, which is in turn good for preventing cheating or code sharing. They won't all have to share the exact same code, meaning they can write it themselves, hopefully a little more motivation to do so. For this one, I'm going to create a model solution to leave my template code untouched. You're welcome to solve this on your own. I'll just write a model really quickly. So reading an integer, age equals sc.nextInt. You're the scanner to the next line there, and then string city equals sc.next line. Then I'll just print out a message. Very simple. I'll just say the city and then a space and then their age +5. You can, on your own, you're more than welcome to write whatever message that you like. I'm just trying to get the simplest output I can right now. I'll make sure that it runs. Hope I didn't make a silly mistake. I frequently do that on my Zoom classes. I don't know about any of you. I'll type in 25 and Barcelona. And I print 30 and no Barcelona. So I messed up my scanner. What did I do?
I think you don't need line 11.
Oh,
You have next int and next line.
Okay, let's see that. I do. Uh-oh.
It's been too long since I've written Java.
it's been too long since I've used scanners. This is like Unit 2 stuff for me in my AP class. Let's see if anyone else has noticed my error. I see dot next line. Oh, well, that's not a city, but that's, yes, thank you. And will it pick up the empty space? So what are you asking, will the autograder pick up the empty space? Yeah, I was concerned about, yeah, exactly. I was concerned about the new line character after the 5 and 25. I didn't realize you had to say next line instead of next. It's been a while. Thank you. All right, let's write that autograder case.
There's also another question above there, just talking about, do the variable names matter? And I think that's important. That's something that people sometimes get hung up on with the autograder, and let's say like an input-output test like this. So if you want to take a second, Evan, just explain.
Right. So all the variables for the student's code, they remain local, and they're only in scope inside of their own methods. You can't really see what their variable names are. How the students represent their own names. And that means you don't have to care about what they name them either. If as long as the strings, like the output matches, that's all that matters. It's for our autograder tests, we'll be able to check what they're printing or what their methods can return. There are ways, if you're, especially at the beginning of the school year, if you're trying to test, the basic skills, like declare an int whose name is age, and you want to see that they actually say int age somewhere. You can take their Java source code file and parse it as a string. Like you can just read the file as a big long string, and see if it contains somewhere in there int age. I'll show you that in our last example, where we kind of grade a complete class. All right, so I'll go to our test bench. I'll make a new case. And for this one, I'm going to make 2 tests. One of them is going to test to make sure that our output contains our city that we typed. And for the other one, I'll make sure that we can contain the age increased by 5. So for the first one, I'll do a city. Input output comparison and add. We'll go to contains an exact value at least once. So this, we have to make sure that it contains the city that we type, and the case does matter for this. So if we type in any number, and then we type in some other city, and I like to use examples actually other than my example cases if I'm making my own tests, just to make sure that they're not copying my exact program's output and making that a print statement. You're more than welcome to use the example code, of course, but if you're only running one test, I would make it something different. And then we need the output to contain somewhere in there Paris. If I scroll up here and go to run test on the model solution, we pass. That's great. And then we'll add a test case again for their age. Input output comparison. And I'll use some different input. 12 in London. And output, we want to see the number 17 somewhere in there. So again, we'll run the tests. And when I hit run test, it's going to run all of the tests, not just the one that I have open. Oh, I failed. I forgot to change the flexible equality to contains. There we go. There we go. If I'm clicking around too quickly, let me know. I don't want to be going too fast here. So that's it. For a more thorough test, you might want to add one other city and one other age just to make sure. I always like to have multiple test cases just in case to figure out what the one test case is and just print out that one test case's expected output, which is definitely a thing.
We do have a couple questions in the chat, Evan.
Okay, why not put both outputs in one test? So for this test, it has to contain an exact value at least once. It can only check for this exact 17. I couldn't put 17 and another value unless I wanted it to be in an exact format. The way that I made this test, it's like if the program printed out a full sentence instead, when you're 30, I'm sure you'll make it to Barcelona. This should still pass my autograder. So by separating them into different cases, I allow for a little bit more personalization. If you're going for an exact output, like I want you to print a sentence that looks exactly like this, then you can definitely make that just one. And then examples of feedback that I would give to students. Right, that's a good question. So here I haven't put any feedback for my failed test case yet. If I am, so my feedback is something, it could be directly using the numbers that I'm giving them. If I am 12, now the program should print 17 somewhere in the output, right? You can either tell them exactly what test cases that you're using, or you could say your test case did not include the person's age plus 5, something a little bit more generic. either one is up to you. Sometimes I do a mix of both if I have a bunch of different tests. And then adaptive, Emily, by adaptive feedback, do you mean, actually changing this feedback here to depend on what gets entered in down here?
More like, so like if I don't know if it's possible in coding rooms, but like if the output doesn't match 17, but it matches 12, like, can you specifically remind them that it's for 5 years in the future or something like that?
I don't, and Joe, you can tell me if I'm wrong. I don't think with the input output testing, you can do the sort of like if statements, but there is a way to use unit testing, which is like the next thing that I'm going to talk about. You can check the output and see if it contains this value, say this. If it contains this value, you can print something else.
Okay.
Exactly.
Okay.
Thank you.
Welcome. Anything else that's on anyone's mind right now for input output testing before I move on to unit testing? And if something comes up later, please don't be shy. I got all night. All right, so here we'll use a single method. We're going to test the return value of one method using a JUnit unit test. What is a chart output?
Oh, so like, this is Bhupinder speaking. I've had a lab where they do it's basically a 2D, it's a nested loop where they have depreciation every year is on one line. So that's what I'm sort of counting as a chart. Basically, it's a chunk of code that looks like a chart or has multiple lines as the output. Does that make sense?
Yeah, you can definitely test against multi-line output. I kept really pretty simple examples here, but in our test benches, I can add more lines down here. So if you want their output to have like a grid, every number separated by some character, however you format it, you can do that output matching as well. I think the white space in between would matter, Joe. I think that, right? Like, so if I have,
depending on how you build a comparison, but yeah, any characters, it supports any characters. My recommendation for ones like that always is for people, run your model solution, copy the actual output from the console for that, just so you don't mess it up yourself as a teacher, and paste it in. But certainly it becomes a little bit more of a game, or harder to build really flexible tests where you can set up the compare method. Some people have built their own regular expressions that kind of ignore certain things and care for other things, but it's a little bit more work.
Yeah. But I for some of my assignments, I get really into the autograders because I like to try like every single possible output. And that's fun on its own. It's like a coding problem for the teachers. But yeah, multiple line output, it's totally fine. All right, so unit testing. On the short little information page here, I link to actually Joe's website, which has a lot of really good resources for auto grading. Both I've seen his stuff on Python and Java. He also has stuff on Ruby, which I don't teach, but you might. And lots of really common methods that you'll use. Most of them are assert statements, which is saying I expect this value to be this, but your value said this instead. That's what most of our unit testing is going to be. And then he had, a nice rundown, sort of a review. And he also has a bunch of other previous versions of an auto-grading webinar on coding rooms using, I think, the old version of coding rooms, but the interface is essentially the same for the autograder in terms of your input output options and your unit testing options. So for our assignment here, we're going to write the method find max, which takes an array of ints, and it finds the largest value and returns the largest value. And our autograder test is going to expect that given a few different example arrays, our find max method will always return the correct value. So let's get started with that. I'm going to write the model solution first to make sure that I kind of have my problem set up correctly. And then once I have that, I'll go into the test bench and write my own solution here. So find max. The JUnit autograder doesn't have to only work on methods, Dana. Like you can run a main method using the JUnit autograder and then read the output. You know, you can basically send any printed output, for example, you can send it into I forget if it's a scanner or some other, you know, kind of like stream, and then read the output as though it's similar to the input output testing. So it's like you can do things that aren't just testing return values. That's just mostly what I use for my own autograders. But Joe has a link on his website as well for like void methods or static, you know, kind of print oriented methods. Is that
Okay,
where
thanks.
you're?
Yes,
okay,
thanks.
for that?
Yeah.
Welcome. Okay, so find max. My solution here, it's guaranteed that the array has one value in it at least. Max equals nums is at 0, and then a for loop. There goes the every number in there. If num is greater than max, max gets num. Return max. I don't see any silly errors in there. Cool. So now we'll go into my test bench. I'll write one autograder test and compare it to the model solution. And then we'll probably make a few others as well. I'll start with a very simple one, and then we can build up other options as well. So now when I'm adding my test case, I will change it from an input-output comparison to a unit test. Now we get down into the unit test code, which looks different because now we're running code to run the student's code instead of just interacting with the, you know, the sort of quote, the terminal when we're typing things in and expecting output. So there are three kind of components to the coding rooms test. There is a before you run the code and after you run the code, and then as many tests as you would like to run. Before and after are both optional. And for most of my assignments, I don't actually use them. You might use before if you want code to run once, like setting up some very large instance variables, you know, like instantiating objects that would take a while to run and you don't want to do it over and over again. You can do that in setup once before you actually get into any of your test cases. And then after, if you have any sort of tear down code, if you want to, you know, deallocate something, or if you want to print some things out before the autograder is completely done, you can do that in the after as well. But for a lot of mine, I just go through and I delete them. They don't have to be there at all. And I just focus on the tests. So we're using JUnit, and JUnit relies on annotations like this. So we have to have an @test before any one of our test methods. So you have an @test and then some public void that takes no arguments. So I'm going to rename my public void to be whatever I want. I'll call it test array of 3. And it'll test an array of 3 numbers. So, you know, int example equals 3, 1, 4. And now we're going to say assert equals, which is my most common assert statement that I write for my autograder tests. Assert equals takes 2 or 3 arguments. The first one that I'm going to show you is the one that just takes 2. And that is going to be in this format. The first argument is the expected return value. So 4. 4 is the maximum in that array. So I expect this to return 4. And then I'm going to say main dot find max with that example array. So what that's doing is it's going in and it's running that static method find max, passing it that example array as an argument. And we're expecting that it returns 4 coming back to us. Let's see what happens when we run that on the model solution. We pass, and we don't get any output at all about the test cases in this case. If we pass it, it's not going to tell us like what worked. But I'm going to go in, I'm going to introduce an error.
I'm sorry, what was that second parameter that you had there?
Oh yeah, so the first parameter is the expected value, and the second parameter is like the actual value. So we expect main.findMax to return 4 for this example here.
Now, that's because the student's file is named main.java also.
Yes.
So
right.
if the student's file and class was different, it might be different name, things like that.
Okay, thank you.
Was that what you're looking for?
Yes.
Okay. I'm going to introduce an error into my model solution here. In this case, I'm just going to say that the first number is the maximum. And let's see what our autograder does in this case here. Yes, Linda, that's a good one as well. Assuming that for like a maximum method that everything is positive, I would definitely make an all negative numbers test for this. If I run the model solution here, now we get failures, 3 exclamation marks. And right here, you have to teach your students, in my experience, not to ignore the error code on this because it's really scary looking. But just go up to the top and see where the error is. Expected 4, but was 3. So that is all that the autograder is telling them, which is not helpful in most cases, right? We don't know what the input data is. So we don't know why we're always returning 3. So I showed you this assert statement here that has the 2 arguments, but I prefer to use the one that has 3 arguments. I'll add one more at the very beginning, and that is the message that comes up if they fail. So you fail with the array 3, 1, 4. And you can also include in that print statement, like you can run main.findMax and then run it in there again if you want. Doesn't matter. If I hit run the model solution, now we see the error message. You see 314, and then that's what it returned. Expected 4, but was 3. So it still includes the expected and the actual values, but now with that first parameter, you can tell the student what your input data was. And for a lot of my autograder cases, I like to tell them what that input data is. So that's how they know where to start looking for their errors. If you have multiple tests that are running on different arrays, and they notice that they're always returning the first value, that's a good place to start looking.
One of the cool things we just implemented, we updated the summary area to actually use a full terminal instead of just like kind of pulling the output, which allows you to actually customize some things. So some things I like to do, Evan, if you want to go back, just because we have a good opportunity for me to showcase some of this stuff. And Evan puts like in front of that string there, like a \n for a new line, maybe. So right in front of the U.
Right here.
That's the first thing, yeah. \n, and then puts like this escape sequence to kind of color it red that I put through in the chat, if you want to copy that.
Like before the \n?
Right after. Yeah, just hit backspace once. One time, yep. And then at the end of the string, after you show your little, yeah, right there. So yeah, just concatenate. Yeah, there, paste this in just to reset back to not red. There we go.
Oh, interesting.
End of the string. And then watch when we run this. You're still gonna fail it, right? I forget exactly.
Yes, I am. Yeah. Okay, so now I fail it. Oh, that's cool.
See that?
Nice.
So it colors the error red, something like that. So we're able to support that kind of thing where you can customize the console output. So you can really create some really nice looking messages for your students. Yeah, so Evan, they would like you to that whole statement, yeah. And so if you look up ANSI color codes, that's how you can get the kind of those escape sequences of strings. So that's ANSI color codes, something like that on Google. You'll get a bunch of colors, and there'll be other things. You can underline text, bold text. So ways so that you can stylize terminal or console output. But we now support that in your tests.
Awesome. I will now be using that because my students are, even though I teach them what to look at with the assert like error feedback, they still don't read it very frequently. If I can make it red and bolded, I think that's going to go way better. Awesome. Thank you, Joe. Yeah, so I did paste that massive assert equals statement right there in the chat. So now we can add other test cases. And for this, we don't actually have to add a brand new test case up here if you don't want to. You can. Maybe we have one sort of suite of tests that only does short arrays. Maybe you have a separate test case that uses much longer arrays. Either way is fine. And you can change how many points that the entire suite of test cases is worth. So if I add a second test in this unit test code down here, saying at test, where am I typing? Here we go. At test, public void, short and negative. Thank you, Emily, for that link. Here I'll make like I think it was Linda who suggested an all negative input. So I'll do int example again. -1, -2, -3. Actually, I don't want to have the maximum being the first one, just in case. I'll say -10. There we go. So now I expect it to return -1. I just pasted in that example code from earlier because I already had it on the clipboard. -10, -1, -2, -3. We expect it to be -1, but it was actually whatever they printed out instead. If you give them input data, do they hard code it? Oh, I see. That's not typically so. Like the problem where if students are, wait, did I scroll up for that, or did you delete the message? Oh, I see. I was reading the message from like 10 minutes ago, 5 minutes ago. But yes, if typically if I give them autograder output, I haven't personally had students like hard code for that solution, but only because I think I give them a lot of test cases just to discourage them from running, a bunch of different if statements to check for each of the autograder outputs. You could modify one of these tests to do a for loop that runs 10,000 times, generates, an array of like a random length and fills it with a random series of numbers. And then you kind of change the autograder output that way. That makes it really hard to kind of predict what's going to happen. So a little bit of randomness. And there's no reason, like you can have your own find max right here. Like you can say static int find max feature. And you could say, instead of the expected value being 4 here, you could say the expected value is actually, find max teacher with that example, right? Does this make sense? Am I making sense? Like write your own example code right here in the unit test, so that your teacher's like solution output is always tested against the student's output.
So that would be like instead of doing a model solution?
Yeah, it's like writing a secret model solution that's only inside this unit test. To my knowledge, and Joe, you could teach me something new about this as well. I don't think that you can run the model solutions code against the student's solution code. Okay, yeah.
Although we are working on it, and it'll should be out soon. You'll be able to release the correct answers to students if you want to at a certain point after the submission cutoff or whatever it may be. If you want to release the model solutions and correct answers for even multiple choice questions. What I was going to mention is it's a really great when you have something that's more of an advanced function and you want to generate random numbers, you want to have lots of tests. That's exactly what I do, exactly what Evan did, is I just really copy and paste from my model solution or something like that, the method as I'd expect the students to have it, throw it in the test bench, and I just call the one that I know is going to work right as what I would expect the students to output given the same values. And it's super easy to just do it that way, less thinking on your part, right? Instead of like figuring out exactly what it should do with these values type of thing, you just give those values to the method and whatever it returns, and then the student should return the same.
So I'm writing really quickly as an example for you all to be able to reference later when this course gets released on the marketplace, like a for loop that does exactly that. Let's see. Three random numbers. And my code is ugly for the sake of speed. I'll say that. How about that? And then the assert equals here again. I'll run my own teacher's code. Is anyone familiar off the top of their head with arrays? Is it arrays.toString to turn an array into a string? I've done this a million times before. Perfect. Thank you. Import Java to util. Let's see. You fill it with the array plus that. I think that'll work. Yes, yeah. I usually am typing this in an IDE and then pasting it in if I'm writing code like this. Okay, so let's find out if I passed that test with my model solution. Did I fix the model solution? Because I didn't want that output. If it, by the way, oh, actually, I'll leave that. I'll leave the error in. If I run the model solution right now, I'm going to fail that test for sure. But here's kind of what happens here. So you can see there's one, it says there's 3 failures, even though that for loop ran, allegedly it ran 10,000 times. So there's one test, that's the array of 3 that I failed because I only returned the first number. If I scroll down, now I can look for the red text, which will make it a lot easier to find. I failed short and negative because it returned the first number there. And then for the last one, I failed just one array right here. And it doesn't print out 10,000 other arrays. So for each one of these test cases, if it finds one assertion that fails, it stops that entire test case. So that's something that's good to know. So if you have multiple assertions, which you can do in the same test, as soon as there's one where they don't pass the assert, that test case is over and it moves on to the next one. So later on, if the student finds their mistake and uncomments their for loop that did all the actual work, and then we run the test case again, now it'll run and we pass every test. and it won't tell us our input again, but it takes a little bit longer to run 10,002 tests than it did to run just 2 of them. So when you get this course, you'll be able to see that for loop example right down there. Questions about unit testing? There are a few other assert commands you can use as well besides assert equals, and I linked them on that example page before find max. Assert array equals to compare to arrays, assert null or assert not null to see if something is null or not. It's really good. It's really, really good. And then finally, testing a complete class. How many AP CSA teachers do we have in the chat tonight? Do we have any? All right, we got at least 2, 3. Okay.
Probably more people shuffling to find that raise hand thing on.
Okay,
Zoom.
cool. Yeah. So this is question 2 from this year's exam. I took it. It's publicly available, so I think it's okay and fair use for me to use it. If not, that's on coding rooms, not me, I guess. But here you can write code to test a complete class using different input methods. So for those of you who weren't there, who haven't seen the questions yet, maybe this is an write a complete class kind of question where you're writing a subclass of some class called book. And I gave you the solution code right here on this page. And then if you go to the problem statement here, there's a main.java, which I left blank. You can write some test cases there if you want. I will not do that today. I give you the starter code for book. If anyone's seen like Maria Litvin's runnable projects, she does this sort of thing every year with her classes, copies all the AP questions and puts them in a runnable set of Java files, and it's really useful. So here's like the starter code. They have a class book, and then they have to extend book.java into a textbook class as well. And my model solution is out here. It already works. I didn't want to solve that whole problem for you right now. But if I'm trying to see, did they get all the possible points that I think they're going to be tested for on the rubric? What I'm going to do is I'm going to run some unit tests on those methods to see if they're returning the right values. But I'm also going to actually parse the Java file and see if they wrote it the right way, right? Almost certainly there's going to be a 1 point on the rubric for writing exactly the class header, public class textbook extends book. Or maybe on like some other large, unrelated coding project, I want to make sure my students actually wrote comments. I can take this .java file and like read it as a text file and look for strings that are // or /* or public class textbook extends book. Let me show you kind of what that looks like as well. It's either far from perfect in terms of the ability to, you can't test for quality comments. It's very hard to know exactly where in the program relative to the other parts of the program they put certain strings. So maybe they put public class textbook extends book at the very end for no reason. You would be hard pressed to find that out using only an autograder. This doesn't completely eliminate you needing to read the code, but it's a really good first step. Okay. So here I have 4 different tests for a sum total of 10 points, even though APs are only worth 9 points. I can adjust those weightings later, I guess. But here's testing for the method header. And I stole this example starter code from Joe's website right here. So because this autograder program is actually running in the same directory as the student's code, we can just read that student's code like any other input file for our autograder here. So here I'm just reading everything from textbook.java, which is the name of the file that they were editing. And then I just put that all into a string. And I'm just saying that the index of that exact header is greater than or equal to 0. So that header is somewhere in the file, probably right at the beginning, but maybe not. That's how I test to see if the header is in there. And if the student doesn't have that header, they don't get that autograder point. I'll do something similar for, calling to the superclass. I want to make sure that they call the superclass constructor, but they don't call the default superclass constructor. So I've written two assert statements here. One of them says that super is somewhere in that file past the very beginning of the program. I could try to say it's past the start of the constructor header as well, but that gets really complicated really fast. I wouldn't bother with that probably. And then I also say that the index is, not that the index of the default superclass constructor is -1. It's like it's not in there. Wonder if we can use. Yeah, like definitely play around with this. It's kind of fun to figure out all the different ways that you can parse these strings, and you can get super detailed if you like. But I found that the more ways that I test for my students' code to be written a certain way, the more ways they baffle me with how they don't write it that way. It's amazing. Call it creativity or call it desperation. It's fun. If any AP graders, I just did my first one last summer, and that was an eye-opening experience. The different ways that they can solve those problems. Right here, I'm looking for, is there a private int declared somewhere in the method? So all three of these examples, I've tested to see if they have actual bits of code written in the file. Then finally, I just have return values. So here I'm calling the constructor for that student's textbook code. Textbook TB equals new textbook. If this line crashes, like if they didn't actually write that constructor, then this test fails. So that's good. If they wrote the constructor wrong, then the test will not proceed, and it will be marked as incorrect, which is good. I'm testing the constructor as I go. Then later on, I can call get titles for both of them. Here I can get the additions. I can get the book info and make sure it's in the right format. And then I'm testing all the different kind of permutations of the can substitute for to make sure that everything works out okay. And note that I put multiple assertions in the same test. That's fine and probably good. If you're testing something that's complicated, you want to make sure that there's no confusion with static versus non-static, or any other interesting behavior that might arise if you make two of the same object, something like that.
What's the difference between assert true and assert false?
It's exactly what it says. So assert true, I'm saying I need this statement to return true, and this statement should be false. So TB2 can substitute for TB3 based on the rules in the problem, but it cannot substitute for TB4. And it's the exact same as saying, assert equals, true, and then this expression here. It's just that the folks at this JUnit software just kind of simplify that into one method. So the other assert statements that you might use are assert not null, which just means that it's whatever value is coming out of there is not a null value, or what else? Assert array equals for comparing actual arrays. Make every element in the array is just, the same order and the same length and all that kind of stuff. And that's what I have for testing a complete class. I think this is my most detailed, test that I have today. And I have a pretty thorough write-up in the information page for this test, just because it's a little more nuanced, and it kind of talks about unit testing and also reading in from the files. So when you get this course, you'll be able to read through what I wrote and find all my mistakes and all that. Yes, Joe pasted his link to the different autograder assertions. That's all the examples that I have for this webinar. I know we're pushing up on an hour here. I hope I was able to keep your attention. And I hope that I've been able to kind of help you, feel confident getting started with autograders. I so recommend them. They're worth the effort to set up. They really do pay dividends. If there are any questions, drop them in the chat or let me know. I'll drop my email right down here as well. If you're having trouble with your own thing, feel free to ask me. Of course, the coding rooms people are also super helpful, but I'm happy to help you as well.